Right, okay, we're going to look at forces today. Now we're going to start off with some GCSE forces and we're going to work up to what is AS level forces. So, first of all we need to look at forces in situations where they're differing. So we've got three situations here. I'm going to draw three cars. Two where the forces are unbalanced and one where they're balanced. So it's 1, 2, 3. Right, okay, so all of these cars, motion is in this direction. Okay, motion is in that direction. So I'm going to draw some force arrows on the first one. Okay, so you'll have to bear with me a little bit, but those two arrows are the same size. Okay, for the most part, they're the same size. What does that mean about this object's motion? Well, there's two things that this object could be doing. I've already suggested what it should be because of this at the top here. I've said they're in motion. So this means when the forces are balanced in the forwards and backwards direction, we have constant speed. So when we've got balanced forces, we've got constant speed. The exception to that is when we're not moving at all, we also have balanced forces. That's all to do with Newton's first law, law of inertia. So this is a constant speed. Because these two forces are balanced. Next one then, we've got a very large force on this side and a small one on this side. So what is it doing? I've already said this one's at a constant speed, so hopefully you're realizing this is accelerating. Now ask yourself a question, is it accelerating constantly or is the acceleration changing? So ask yourself that question. The correct answer should be that it's accelerating constantly. It's accelerating constantly because this force is consistently larger than this one. You've got an overall external resultant force. You've got an overall external resultant force. And that external resultant force is the difference between the two forces. So for example, if I've got air resistance or resistive forces that equal to, 5 newtons, and we've got an accelerating force which is 15 newtons, then that means that I'm going to get an overall force, or a net force, of about 10 newtons. So that means I'm accelerating with 10 newtons of force, and that is our external resultant force. And that's what's giving rise to our acceleration. On the other hand, we've got the very final one, where it's the opposite way around. In this case, what's happening? Well, it's still a constant form of acceleration, but it's in the opposite direction to motion. Remember, motion is in that direction for all of these diagrams. So what we've got here is a situation where we've got our external resultant force opposing motion, and so you're getting deceleration. Because it's in the opposite direction of motion, it's a deceleration. Technically, it's still an acceleration, just in that direction. We just use the word deceleration to suggest the acceleration is occurring in the opposite direction of motion. So again, the same principle applies as above. You take the difference between the two forces, the external resultant will give you an idea of A, the direction of the acceleration, whether it's acceleration or deceleration, and the external resultant force as a magnitude as well. So that is some base GCSE knowledge, stuff that you should be happy with. Do obviously go back, have a look at some of your GCSE books if you're not 100% with some of that stuff. I'm going to leave the middle one on the board. So, in your GCSE studies, you will have learnt what the unit for force is. It is the Newton. 1 Newton allows for 1 kilogram of mass to be accelerated by 1 meter per second. So if I wanted to work out what the acceleration of this object is, I need to use an equation. And it's an equation that gets used a lot in physics. Force equals mass times acceleration. Because, as I've just said, I'll repeat the definition of the Newton. 1 Newton is the amount of force required to accelerate a mass of 1 kilogram by 1 meter per second. Okay? So, what we've got here is force equals mass times acceleration. So if I want to work out the acceleration of an object, I need to rearrange it. Acceleration equals force over mass. So if I wanted to work out the acceleration of this object, what force would I put in there? Well, I'd need to know the mass, but we're not too worried about that right now. It's just a figure that we can find out later. What force am I going to put in there? Now, common misconception is that we put the full forward force in. That is wrong, okay? You don't want to put the full forward force in. This equation is all based around the external resultant force. The external resultant force required to allow a kilogram of mass to accelerate by 1 meters per second. So we can use this equation to work that out, and in this case you would do 10 divided by whatever the mass is to work out the acceleration in meters per second. Okay? So, very important equation that's going to get used a lot. A lot of times it's just expected that you know that, and we're going to use that again in another example. Right, that's it for this video. The next video will contain a bit more moving up to AS level situations where we look at forces.